Hello, friends and dear students. I welcome all students of studying in CBSE board. This playlist is about mathematics of class 9 based on CBSE board following the textbook of author R.D. Sharma. In this playlist, I will only discuss about the key concepts and formula related to problem solving. Primarily, I will refer all the problems, example problems, and exercise problems of R.D. Sharma, both the textbook as well as the MCQ problems. If you, but please note that I will not be following the chapters sequentially. All the videos will be random, haphazard. It will be based on any random topic from any random chapter. So you can refer all these videos as a to verify that your concepts are up to the mark, and I will try to solve as many problems related to any particular subtopic of a chapter. So this is part 1 video from the chapter of exponents of real numbers, where I will discuss about radicals. This is the subtopic is radicals, where I will discuss about the principal nth root of a real number, which is principal nth root of a real number. Uh, and if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. Now, if you think I am incorrectly discussing any concept or incorrectly providing any formulas, then I really apologize for that. Okay, so what is uh, what is the principal nth root of a real number? Now, the real number could be positive, and as well as negative. So we need to discuss them separately. So let's say x is a positive real number. Now, uh, I hope you know that the set of real numbers is denoted by the capital letter R. So when I say that a variable x belongs to R, this implies that x is a real number. Now, this is concept from set theory. If you are from ICSE board, you already must be knowing, and if you are from CBSE board, probably you have not studied set. But anyway, set will be, it is highly recommended that you have a good understanding of set theory and set basic concepts of set, as set will be, concepts of set will be heavily used in 11 and 12 mathematics. Okay, now the capital R means the entire range of real numbers, that is positive, negative as well as 0, whereas R positive means the positive real numbers, and R negative means the negative real numbers. So let's say x is a real number. Let's say x belongs to R positive. So we are talking about x, which is a which is a positive real number. Now, about an nth principal nth root. Principal, what is principal nth root? Nth root of x. What is this? Mathematically, what does it mean? Principal nth, first of all, principal nth root of x. Okay, where x is a positive real number, that is x is greater than 0. X is greater than 0. This, the principal nth root the principal nth root of x is also mathematically denoted as this way. This sign, you are familiar with the square root, but actually this is the radical sign. Radical sign, or this is the radical sign. Okay, the number inside the radical sign, which is x is known as the radicand, and this n, n which is specified on the top left corner of the radical sign is the root of the radical sign. So this entire expression is a radical, is known as, is in the radical form, and this is the principal nth root of x, where we are considering x to be a positive real number, that is x is greater than 0. Now this principal nth root of x is also expressed in the rational form, in the exponential form, as x to the power 1 by n. These two notations means the same thing, that is the principal nth root of x, where in the first case we are considering x is a positive real number. This implies x is greater than 0. Okay, now what exactly is this number? What exactly is the principal nth root of x? The principal nth root of x is a number y, is a positive number y. Remember that we are considering x to be a positive real number. So the principal nth root of x, where x is a positive real number, will be a positive real number y, such that if I raise y, so y is equal to nth root of x, which is also expressed as x to the power 1 by n. Y, so what is y? This y is a positive real number such that when y, that number, is raised to the power n, we get the positive real number x. So if there is a positive real number y, so that if I raise that number to a power n, remember n is a natural number. N is a natural number. This is super important. N is a natural number, that is positive integers. So if there is a positive real number y, and if I raise that to the power n, where n is some natural number, and I get the number x, then I say the principal nth root of x is 5. For example, okay, now for example, I know that 2 is a real number, 2 raised to the power 5 is a natural number, 2 raised to the power 5 I know is what? 32. Now if I do any kind of calculation mistake, I really apologize for that. Please feel free to let me know in the comment section. I will highly appreciate that. So 2 to the power 5 is 32. So this implies in terms of radical or principal nth root, I can say that the fifth root of 32 is 2, or the principal fifth root of 32 is 2. So in this example, x was 32, n was 5, and y is 2. This was a very simple example. Now okay, let's take another example. Let's say uh, uh, let's say 2 by 3 square. 2 by 3 is a real number, is a positive real number. I'm raising it to the power 2, where 2 is a natural number, and I know this is 4 by 9. So in the terms of principal nth root, I can say that second root of 4 by 9 is equal to 2 by 3. Now the second root, if n is 2, we actually do not write 2, we omit it, and second root is actually is a term is more popularly known as the square root. So we do not write, if in a radical the n is 2, we usually omit that. So square root of 4 by 9 is 2 by 3. So I hope you got the idea. Okay, so let's say what will be third root and second root. Third root is also known as cube root. So third root of 8, you can definitely guess this will be 2, because I know 2 raised to the power 3 is equal to 8. Okay, now why if the book does not explain why it is called the principal nth root, why not just nth root? What is the significance of the word principal? This is my guess. I don't know whether my guess is correct or not, but anyway, I will discuss, I will share. See, 2 when raised to the power 4 is equal to, we know, 16. Also we know that minus 2 when raised to the power 4 is 16. From this fact, from the first fact, in the terms of principal nth root, I can say that fourth root of 16 is equal to 2. And from the second fact, I can say that fourth root of 16 is equal to minus 2. So this is something strange. Fourth root of 16 is 2, and fourth root of 16 is also minus 2. I forgot to mention one thing, that while I was explaining what is principal nth root of x, I said that if there exists a positive real number y, now this y will be unique. This y will be unique. That is, for a unique positive real number y, if I raise that number y to the power n, and if y to the power n is equal to x, then we say principal nth root of x is y. Here y is a unique positive real number. But see, here we got fourth root of 16 is 2, fourth root of 16 is also, I can say, minus 2. So which one should I consider to be the correct value of principal fourth root of 16? I think we always consider the positive value, that is 2, that is positive 2 is the principal fourth root of 16, not minus 2. So that is the, I guess, significance of the principal nth root. If it was only nth root, then if you are asked to say, if you are asked what is the nth fourth root of 16, then possibly I can say it is 2 or even minus 2. But when it is asked what is the principal fourth root of 16, then I think we should say 2. This is one thing, it was not clearly explained in the book. I thought I would share my own opinion. Okay, so this was the principal nth root of a real number x, where x is a positive real number, and of course n is always a natural number. Now let's see what happens for a negative real number when x is negative, that is x belongs to are minus, that is x is less than 0. What will be the principal nth root of a negative real number? Uh, this is based on the principal nth root of a positive real number. This is equal to principal. This is equal to negative of principal nth root of mod x. What is this? Mod x means whatever the value of x is, positive or negative, you will ignore the sign. That is, mod of minus 3 is 3, mod of 4 is 4, mod of minus 1 is 1, mod of 0 is 0. This is, I hope you are aware what is meant by the mod operator. This is also termed as absolute value of x, or mod of x, or the numerical value of x. They all mean the same thing. So if x is a negative real number, then what will be the principal nth root of x? It will be the negative of, we know that principal, now since x is a negative number, absolute value of x or mod x will be a positive real number. And we also know that the principal nth root of a positive real number is always a positive real number. So now the principal nth root of a negative real number is always a negative number, because the formula is, it is negative of principal nth root of mod x. Now, one thing to understand is that in finding the principal nth root of a negative real number is not defined when the n is a even number. It is always defined for odd values of n, that is odd integers or positive integers. So we must keep in mind that n belongs to capital O, where capital O in general in set theory is referred to the set of odd integers like 1, 3, 5, 7, 9, etc. Okay. Now why n has to be odd integer? Because if n is even, then any power of if you raise any real number to a power of even integer, it will always be positive. But since x is negative, the power n cannot be even, because okay, so we are having basically this is equal to negative of let's say nth root of, what is principal nth root of mod x? It will be, how it will be denoted using a radical expression. It is nth root of mod x. Let's see some example. What will be principal third root of let's say minus 8. Minus 8 is a negative real number. Now we know that if you raise the negative real number minus 2 to the power 3, we have 8. So this implies that, sorry, we have minus 8. Okay. We also know, let me give a proper explanation. We know that when the positive real number 2 raised to the power 3, we have 8. So what will be, so we can say the third root or cube root of minus 8 will be equal to this will be equal to negative of cube root of mod value of minus 8. This is equal to a negative of cube root of 8, and we know cube root of 8 we know is minus 2, so this is minus 2. Let's okay, so by the way, if x is equal to 1, if x is equal to 1, in the case where x is a positive real number, if x is equal to 1, then whatever the value of n be, the principal nth root of x will always be 1. That is, nth root of 1 irrespective of what value n is, this is always equal to 1. Similarly, nth root of minus 1, nth root of minus 1, where obviously n has to be some odd integer. Remember, principal nth root of a negative real number is only valid for odd positive integer values of n, that is odd natural numbers. So principal nth root of minus 1, whatever n be, this is always equal to minus 1. Let's see some few more examples. Let's say what will be we cannot, obviously we cannot find in finding the principal nth root of some negative real number, the n can never be even integer, it will always be odd. So what is let's say fifth root of minus 32, let's say minus 32 by, let's say 27 81, let's say 243. Okay, so clearly the inside the radicand, that is the value inside the radical sign, is negative, and we are having the root is odd. Obviously this whole number should be defined. Okay, now this is nothing but negative of the fifth root of I will take the mod value, mod of minus 32 by 243. This is equal to negative of fifth root of 32 by 243. Now what will be the principal fifth root of 32 by 243? I have to express 32 by 243 as in the exponent as a power of some number, and the power will be 5. So 32 by 243 is equal to, 32 can be written as 2 to the power 5, and 243 can be written as 3 to the power 5. So this whole can be written as 2 by 3. I am applying laws of exponents of positive where the exponent index is positive integers. You have already studied in your previous class. So this is 2 by 3 whole raised to the power 5. So now I can clearly say, I know that 2 by 3 whole raised to the power 5 is 32 by 243. So I can clearly say that fifth root of 32 by 243 will be 2 by 3. So the answer is minus 2 by 3. I think I was able to explain the concept of principal nth root of a positive real number and principal nth root of a negative real number. The only thing you need to remember for principal nth root of negative real number is that the n should be a odd natural number. Even for even natural number, principal nth root of a negative real number is not defined. What else? Okay, now how do we actually find the principal nth root of a given number? Let's say, let me quickly check the book for some examples. Let me okay. So what will be now? Always remember that nth root of x, where x is a real number, whether it is positive or negative, and n is the natural number. This is also expressed as in the exponential form x to the power 1 by n. Okay, let's I'm doing some these are illustrative examples. Okay, let me do some problems from the exercise. Okay, anyway, I am taking examples only, solved examples. Now also remember that the real number x could also be a exponential number. It could also, x itself could be some it could be a rational number, it could be an integer, it could also be a exponential term. Okay, so what is let's say 125 to the power minus 1 by 3. Okay, one more thing is that if you are asked to find x to the power minus 1 by n, where you know n is a natural number, if you you know that if the power is negative, you can get rid of the negative power by taking the reciprocal of the base. So this will be equal to 1 by x to the power 1 by n. So this is equal to 1 by x to the power 1 by n. Okay, so we have 125 to the power minus 1 by 3. Now first, so this is equal to 1 by 125. I am taking the reciprocal of the base. The base is 125. So reciprocal of base is 1 by 125, and this will be raised to the power. The power will now be positive. So 1 by 3. So now I know this is the cube root of 1 by 125. So this is equal to cube root or third root of 1 by 125. Okay. So this is equal to cube root of, the idea to find the nth root of a number is that the fundamental idea is that if you are asked to find the nth root of x, nth root of x in general, that is, if x is positive, then n is a natural number always, and if x is a positive real number, then n could be any natural number. But if x is a negative real number, then n has to be a odd integer. In general, how do we find this? We would like to express the x in the exponential form, so that we would like to express x as y to the power n for some real number y. If we can find the y such that y to the x can be written as y to the power n, then this becomes equals to y. Okay, so 1 by 125, I have to express 1 by 125 in a exponential term where the exponent will be 3. So I know 1 by, what is 125? 125 is 5 to the power 3. So this is cube root of 1 by 5 whole raised to the power 3. So now this is equal to 1 by 5. So this power is matching with the root of the radical sign. This. Okay. Let me see. Now, most of the examples are based on the laws of rational exponents. In the next video, I will discuss about the how to find regarding the powers to be rational numbers. That is, when any real number is raised to some rational powers where the power is rational numbers, how do we deal with them? And some laws of exponential terms where the power is rational numbers. Okay. I think I will end the video here regarding dealing with numbers like x, where x is the real number, x to the power, where the power is a rational number, p by q. I will discuss all this in some future videos. That this is nothing but x to the power 1 by q and this whole raised to the power p. Also this can be written as x to the power p and this whole raised to the power 1 by q. So this thing, if I introduce a radical notation, this will be qth root of x 1 by a power of 1 by q, means where since p by q is a rational number, p and q obviously will be some natural numbers. Obviously q is not equals to 0. So this is qth root of x and this whole is raised to the power p. And in the second case, we are having the qth root of x to the power p. These two have the same value. They are different expressions of the same number, which is x to the power p by q. I will discuss about all these exponential terms in some future video. So I hope I was able to explain what is the principle nth root of real number, and that when the real number is negative, that is when x is negative, then the nth root n has to be odd natural number. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.